And then what are these pins on that microcontroller? I mean, what are these PA11, PP3, PP4, and so on? So I had a look on the datasheet of this microcontroller. So this is not the datasheet of the board we are using, but exactly the microcontroller, which is on that microcontroller board. So, and then there is a block diagram. It's a, yeah, now this is, should I go, okay, I think that it's visible in here. It's not that sharp print on this PDF document, but anyway. So in that microcontroller, there is an internal bus for communicating with the internal components of the microcontroller. So all these components which are seen in here are inside that microcontroller chip. And inside that microcontroller chip, these down here, which are drawn down here, are the peripherals. So meaning that these are for connecting to external devices. And what makes the difference between the processor and the microcontroller is exactly that the microcontroller has a lot of different kind of peripherals. The peripherals are, for example, this general purpose input outputs. So our digital in, digital out, and so on. And those digital ins and outs are in general purpose input output port A, or port B, or port C, or port H. So these were the digital inputs outputs. If we do an analog to digital conversion, so the pins A0 to A7. So there is an ADC converter here. If we do the SPI communication, then there is an SPI communication module in here. There is another SPI communication module in here. So it's got two different ones and so on. There is also modules where no one has written the code in the MPS OS on the operating system, that we can't directly access those functions through the embed operating system, because no one has written there the definition that in which registers are the controls for a certain, like a module in here. But for the most important ones, they have written the code. So for the general purpose input outputs, for the analog to digital conversion, for the SPI communications, and so on. And then looking at the diagram, the central processing unit is drawn up here. And then there is the flash memory, SRAM memory, and so on. That's how the processor, so the microcontroller is organized. And then that is the processor or the microcontroller we have on that development board. And now you see it's got only like 32 pins from 1 to 32. And then if you are using some of these for communicating with the VLAN, wireless LAN unit, the Wi-Fi unit, you lose already like 4 pins or something for that. If you use it for SPI communication with a small display, you're losing another 4 pins. Then there are those always necessary pins like the power supplies and pins and the things like that. So half of the pins are already used. And then you haven't got left that many to connect digital inputs, digital outputs. And that's why later today we have a look at how to like put there an external circuit where you can connect, for example, 64 digital inputs. But then if someone would like to go deep into details that how these general purpose input, output, port A, and so on, how these work exactly, then you can look at the documentation. There is a reference manual, which is about 2,000 pages. And then there is a definition that what you can do with the inputs and outputs and so on. So if you are just like reading an input, that's not all what can be done with an input. So for example, for the normal input, you define the input mode. Input mode is, yeah, okay, I think I have it later in this document. It's got 4 different modes. Output mode also some different modes, 3 or 4. Alternate function mode. So in the same pin, there is always like it can be an digital input, or it can be digital output, or it can be pulse width modulated output, or analog input, or something else. Then when it is in an analog mode, analog input, what is the mode for that one? I think it depends that you can control there if you take one sample when you call the analog input, or if you start streaming the analog values onto the memory of the microcontroller when you call the analog input. That can be set in the mode. Then for an input, there are internal pull-ups. Pull-up is so when you connect there a switch, you typically need a pull-up resistor or pull-down resistor. Quite often those are external components, those resistors, but there are also inside the microcontroller, there are those resistors, and then we can just call that we are using the internal pull-ups. The output circuit can be a push-pull, so then it is capable for sourcing and syncing. At least in this MbedOS, it is on a default. If you don't set there anything, it is this kind of configuration. It's a push-pull, capable of sourcing and syncing. So you can, when you drive an output, you can supply the current to the small current to the output circuit, or you can like ground the output pin through the microcontroller. Then you are taking in the current from the external circuit through the microcontroller into the ground. So it's sourcing and syncing. And then an input can be low speed, medium speed, high speed. So there is some kind of filtering for the switches. So we expect to high speed operations, then the filtering frequency is higher. If we expect a low speed operations, then the filtering frequency is lower, and so on. So, and they haven't written everything on the MbedOS. So it's not at all visible for the normal user who is programming with the MbedOS, all these. But if you would like to specify there something in detail, you need to write in that address area in the microcontroller, and then look at that 2,000 page manual, that where is, in which address is that definition register for which input and output and so on. So that's how the inputs and outputs work in detail.